So last time I was talking about how to do data analysis in Excel here, and now I wanted to do a quick tutorial on how to do some data analysis in Octave, which is an open source alternative to Matlab, and everything I'm going to show you today will work equally well in Matlab, which is a very nice program to use for data analysis, but it does cost money. So Octave is a perfectly viable free alternative for everything I'm going to show you today, and the features of the professional version Matlab are only necessary if you want to do much more advanced things, or if you just want the nicer environment to work in. So what we're going to do is we're going to take this data, which we imagine we just typed in by hand, and so now let me copy all of our data we're actually going to use here, all of our base data, because this is all the values we calculated, but this is all the data we actually took from the video of me driving, the timestamps, the distance markers, and the speedometer readings. So we're going to paste that into a new section here, and we're going to do File, Save As, and we are going to, we're going to do File, and then we're going to do, we are going to do Save As. And we are going to actually export as a comma-separated value, or CSV. So click on the, file type and go CSV. And we are going to just call this speed. We are going to save, and I already have one, but we're just going to go ahead and replace it. And we actually only want to export this one sheet. Okay, so now let's go over to Octave. And Octave can be used in two ways. We can either use it in this command line interface where we can just do, say 1 + 1 and hit enter, and it will give us the answer 2. Or we can write code in an editor like this. Let me make a new file, and we can type 1 + 1, and then we can hit the run button, which is F5, and it'll ask us to save. Let's call it test1, and then when we go back to the command window, we ran the program test1 and it gave us the answer 2. So I'm going to show you everything in individual commands, and then I'll make the file with all of them available in the description, because it won't be that long. So, okay, first let's read in our data. So let's just import it as, let's call it the data, and I say equal to csv read of our file name, which is speed.csv, and press enter, and there's our data. So it's in what we call a matrix, so it's got rows and columns just like in our Excel data, and it's organized the same way. So we could also enter data by hand in Octave. We could say, like, some data is equal to 1, 2, 3, and there we have some data. So, but now let's actually do something useful with the data we got from our CSV file. And let's say that t for time is equal to the data of colon, which selects the entire column, and 1 for the first column, and then press enter. And now t is we call column vector containing all of the time values. So now let's do the same thing for position, which we'll just call x. We'll say x is equal to the data of colon for whole column 2. All right, and then finally let's do the speedometer, which we'll just call that s for speed, and we'll say equal to the data colon comma 3. Okay, so now we have column vectors, and so how do we do some analysis? Let's make a plot out of this. So what we want to do is we want to create a new figure. So type figure. And we're going to say figure 1. You don't actually have to do this, but it will make it quite a bit neater. So we'll say figure 1. So that pops up a figure window. There's nothing in it yet. And then let's type plot, t, our independent variable, and x, our dependent variable. And let's go back to our figure window. And there's a plot, although it's kind of hard to read. So let's make it a little bit easier to read. First of all, let's snap the two windows there so we can look at both at the same time. So first off, let's redo that plot, but let's make some more useful markers. So to change the marker, you, after the two data variables, you just put in quotation marks the symbol you want to use, which we're going to use an X and then a dash, and then let's say B before the X, which stands for blue. And you can look this up on their website. There's different codes for different colors, symbols, and line types. But just for now, let's just use BX dash. Or actually, I changed my mind. Let's use diamonds instead of X's. So let's do BD dash. Okay, so now we've got our data plotted here. And all right, that's a little more useful. Not too different from our plot we had in Excel. You know, same basic idea here, just like this plot on the left. But okay, let's try to do some more useful stuff with it. Well, what else can we do? Well, first of all, let's maybe convert it to more useful units, because right now we have distance in miles on the vertical axis and our time in seconds on the horizontal axis. So, but if we want to analyze things in miles per hour, because that's what the speedometer reads, let's convert our time into hours instead of seconds. So remember, 60 seconds in a minute, 60 minutes in an hour. So t is equal to t divided by 60 divided by 60. Press enter. All right, and then let's you can always go back to a previous command by pressing the up arrow and enter. Okay, so now same thing, but now we have different values here. And so now let's just fix some formatting. We're going to just say set GCA font size 25, and that's going to set the font size to 25, make it more readable. So, and then let's label things. So let's say xlabel time hours, and then let's do y label time, or sorry, not time, distance miles. Oh, forgot my close parenthesis in the, there we go. So there we go. All right, that's looking pretty nice. What else can we do? Well, just like before, we want to add this trend line, right? But we have a little bit more control, and we can do more than just add trend lines, but that's all we're going to do for today. So how do we do that? Well, we're going to use what's called the polyfit function, not to be confused with polyjuice potion. The poly stands for polynomial, so we don't just have to use a straight line. We could use a parabola or a cubic or a quartic or whatever we'd like. So we're going to say P is equal to polyfit. Polyfit of t, comma, x. So we're going to feed it the data, and then we're going to tell it what order of polynomial do we want. And a straight line is a first order polynomial, so we're going to feed it the number 1. And then we are going to press enter. And all right, what did that give us? Well, that gave us a straight line that fits this data. And what does it correspond to? Well, essentially the speed plus some tiny little offset, right? It's, you know, y is equal to mx plus b. Here's m, here's b. So if we want to plot that on the graph, we have to do the command hold on, because remember before it was resetting every time I typed the plot command. So we type hold on, that'll let us plot two things on the graph at once. Or let me show you if I did hold off, what happens. And I do plot t, and we'll do p, so p1, so the first parameter is the slope times time, plus p2, which is the offset. And let's make that line red. See, so that resets the graph. So now if I turn hold on, and I want to plot my previous data now, there we go. And look, that straight line goes very nicely through there. And then because we reset everything, we also have to reset our font size, reset our xlabel, reset our ylabel. And it's a nice thing about this command window is you can always pull up a previous command. If you start typing a previous command and then press the up arrow, it will bring you to the last command that starts with whatever you just typed. Or you can just go through your previous commands with the up and down arrows. It's really nice. Okay, so this is starting to get more useful. Not too shabby. And if we read this number right, 3.575 times 10 to the 1, well, that's, you know, about 35.7, so that's about 35 miles an hour, which is about right. So things are seeming on track. Okay, now let's consider the other set of data. So how do we do that? Well, let's say we want two graphs. We're going to use a command called subplot so that we can have two graphs at once. So I say subplot, and then 2, 1, because we want a 2 by 1 set of graphs, and then comma 2, because we want the second one. And watch, it's going to get rid of our first one. Yeah. So that's fine. We'll put the first one back in a minute. But for now, let's just do plot of t, s. And then let's make this one green circles, because why not? So green makes it green, O makes it circles, and dash puts a line there. Which, if you don't want the line, just do the same thing but with no dash. Dash puts the line there. Okay, that's not too bad. And let's set the font size, do our xlabel, and then our ylabel is no longer distance, it's now speed. All right, not too shabby. Now let's go to the subplot command again. So 2, 1, so 2 vertically, 1 horizontally. And instead of 2, let's go to 1. So that gives us the vertical one. And then now let's plot our data from before. So our red line, hold on so it doesn't reset it, plot, and then, oh, there we go. Plot our data, and then again, set the font size, xlabel, ylabel. And there we go. We have almost everything we want. But remember, we also, this is a tutorial on data analysis, so I'm not going to talk about what average and instantaneous speed are, but we want to sort of compare the speed and the average speed over these little intervals to the speedometer readings. So let's find a way to do that. Well, we're going to use the difference, the command, or diff, which is just going to take the difference between the data points, subtract each one from the previous one. So let's say speed, which is distinct from just s, or let's call it, well, yeah, let's call it avg speed for average, and we'll say that that is equal to the difference of the distances, and then dot divided by the difference of the times. If you want to divide individual elements by each other, you have to use this dot divided by. And then let's go ahead and press enter and see what we get. that's looking pretty good. So now what happens if we plot that on the graph? Well, it's not going to be quite right as is. So what we actually need to do is plot t sub 2 colon end, because we want, there's going to be, well, actually, let me just show you what happens if we just try to plot t comma avgspeed. It's going to give us an error because the vectors have to be the same length, right? Because the difference command needs a difference between data points, so you're going to have one fewer than you did in the original data. So we're going to do two things to fix that. We're going to do t sub 2 colon end, which will go from the second element to the end, because Octave and Matlab index from 1, not from 0. And then we're going to actually do an offset of that from that. So we're going to do minus the mean of diff of t. And then let's make that also red. What should we do? Let's do red x's for that, and then let's put a line there. Oh, selected the wrong subplot. So we have to select the bottom subplot. Oh. Also, if you get the parameters wrong, it resets it, so that's fine. And we can always pull up previous commands this way. Hold on. All right, there we go. Now that's actually starting to look not too shabby. Although, actually, that's not quite right. Oh, I've still gotten this wrong. Okay, so let's do clear figure, CLF, subplot, 2, 1, 2, 1, 2. And then let's plot this difference divided by 2, because we only want to offset it by half of a time interval. And then hold on. And then let's put speed back on there. All right, so now that matches up quite nicely, doesn't it? So now let's set the font size, xlabel, ylabel. All right, so now we have a pretty nice plot, and we can see the speedometer reading giving us instantaneous velocity agrees fairly nicely with the reading on velocity from the average instantaneous velocities roughly match, which is good. And you can see compared to the Excel graph, they match better, because in Excel, doing that offset is a bit more of a nuisance. So in Octave here, we're actually doing it correctly. All right, so now let's go back to the top subplot and put that back on there. Subplot 2, 1, 1. And then plot. And wait until we have, there we go. Oh, there we go. Oh, hold on. Put that back. And then set, and then X, Y, and there we go. We have a completed graph that looks pretty nice, and it's showing us how we can draw a straight line through the data points that gives us a pretty good measure on the speed, and we can calculate the average speed, and it matches decently with the instantaneous speed as a function of time over these different intervals. And you can also take all of these commands and put them into a script like this that will give you a much more efficient way of doing this, because you can rerun your commands by just pressing F5 and see this script I have here has all of the commands I just typed out, but rather than going through them one by one, it just has them all in a file. But of course it's harder to understand what they do that way, so just press F5 and it generates the figure. So yeah, hopefully that explains the basics of how to use Octave/Matlab. You can download Octave for free and use it. I would strongly encourage you to do so and play around with it if anybody is actually watching. But yeah, it's a fantastic little program. I think it's great for data analysis. Bye.